All right, so welcome to week 8 of distance learning. We have this week and next week for our final mini exams for your final assessment. And then week 10 will just be like a wrap up, easy work, complete things kind of a week. So hang in there, we are almost done. What we are talking about today are rational expressions. And something we've mentioned in class several times is this. When you see this word rational, notice that base word in here of ratio. And a ratio is something where you're comparing two pieces of information. Sometimes you'll see it like written with a colon, like you'll say 2 to 3 if you're comparing stuff. But you can also see it written as a fraction. And so whenever you see this word rational in math, it's something that can be written as a fraction. And so today we're talking about not just things that are fractions, but things that are fractions and have variables in the denominator somewhere. That's what makes a rational expression. And the things that we've done with rational expressions are basic operations: add, subtract, multiply, and divide. And then we have also solved rational equations. And so those are the things that we're focusing on reviewing today. So in number 1, you'll notice that 1 and 2 actually go together. They have the same expression, the same fractions that are being added. The reason why it's broken up is because there's several processes going on here. When you're adding fractions that do not have the same denominator, just like this, you have to find a common denominator first, rewrite the fractions using that common denominator, and then you can add. So I'm going to show you something with just regular numbers real fast. You don't have to write this down. It's not part of your notes. It's just a quick review of fractions with different denominators. Like if you wanted to do 2/3 plus 4/5, you first have to make the denominators the same. And you have to ask yourself, okay, what do 3 and 5 go into? Both of them go into so that they are the same number. And that number is 15. It's called the least common denominator. And you would rewrite your fractions by multiplying the 2/3 by 5 on the top and bottom, and take 4/5 and multiply it by 3 on the top and bottom. And then when you're multiplying fractions, you multiply across the top, across the bottom. So this would give you 10/15. And this would give you 12/15. And now that they have the same denominator, you can add them with 15 on the bottom stays the same. And then you add the numerators. 10 plus 12 is 22. Now that's basically the same thing we're doing here, but when you put variables in the denominator, it changes the process or the procedure a little bit. But this process is a basic idea. So here we go. Oh my gosh, who is sneezing? Stop it. I'm making a video, you sneeze like 10 times. Tell your sneezes to wait. The corona. All right, so number 1, find a common denominator. So let's look at our denominators we have right now. 3x and 12x squared. And think about that in chunks, okay? 3 and 12, both can be, you can use 12 as a common denominator. X and x squared, you can use x squared as a common denominator. If that's something that comes naturally to you and your brain automatically figures it out real quickly, good. Kind of skip over the next part of the video or just tune it out for a second. What I'm going to do is give you a procedure for finding the least common denominator, even if it's not something that you can just look and figure it out, like it doesn't just pop out of your brain quickly. What you can do is this. You can start by just going ahead and multiplying both denominators, right? So this is your first step. Multiply the denominators. All right, so that would give you this, 3x times 12x squared gives you 36x cubed. Now, that's good. It's actually bigger than you need it to be. And the reason why that's important to talk about is because the bigger your denominator is, when you go to rewrite your fractions, the bigger they'll be. And it increases your chance of making a mistake. So we want to use the smallest common denominator that we can find. So once you get that 36x cubed, to make it as small as possible, the next thing you're going to do is divide by the GCF of your two denominators. So the GCF you'll take in chunks. Look at the 3 and the 12 first. What is the biggest factor that 3 and 12 have in common? Is 3. And then what's the biggest number of x's that x and x squared have in common? And it's x. So if you take that 36x cubed and divide out what they have in common, you get a least common denominator, okay? And this is the same answer you'd get if you were just doing it in your head. But if it's hard for you to do it in your head, then you have these steps to help you out, all right? So now that we have the least common denominator, we will go to number 2, where we're actually going to rewrite using that and then add. So looking at this first fraction, I'm trying to get the 3x to be 12x squared instead. So I have to multiply the top and bottom by the same thing. There's people in my house are making so much noise. All right. So 3x times what would give you 12x squared? It's 4x, right? And you need to multiply that by top and bottom. And then plus, now we've got the second fraction. What do we need to multiply the bottom by? Nothing, right? It's already 12x squared. You could technically multiply the top and bottom by 1. It's not going to change anything, right? And so now we're still in the process of rewriting with the LCD. We're going to multiply across the top and bottom. But in that first fraction, notice the blue fraction has 2 things in the numerator, 2 terms, 4x minus 2. So when you go to multiply this 4x across the top, it's really a distributive property because you've got to multiply it times this 4x, but also times the negative 2. So here's what that looks like. Next, 4x times 4x is 16x squared. And then 4x times the negative 2 is negative 8x. And on the bottom you have 4x times 3x, which is 12x squared. And then on the second fraction, it's still x plus 2 over 12x squared. Now that the denominators are the same, you add across the top and bottom. So I'll be adding this 6x squared minus 8x plus x plus 2. So you want to see if are there any like terms in the second fraction that can combine with 16x squared? No, because there's no x squareds over there. So that stays alone. Is there anything in the second fraction numerator that combines with negative 8x? Yes, right? This positive x. So negative 8x, positive 1x is negative 7x. And then nothing combines with this plus 2. And then it's all over 12x squared. Okay. And also look in the filled out notes, the PDF I've given you of the notes that are completed, because I have some more explanations there that I verbally said in the video, but if you want to see it written down, it's on those notes. That might be helpful if you're a visual learner. Okay, so we just added 2 rational expressions with unlike denominators. Now we are going to do a division of rational expressions. So hopefully whenever you see fractions being divided, your brain starts firing keep, change, flip, or multiply by the reciprocal, right? So we're going to do keep, change, flip, keep the first fraction the same, change the division to multiplication, and flip the second one, also known as multiply by the reciprocal. So, so that's what we're going to do. So step one, keep the first fraction the same. Change the division to multiplication and flip the second fraction. The next thing we want to do is factor anything that can be factored. And the only part, so you're looking at all the numerators, all the denominators. There's 4 different places you're checking to see what can be factored. And the only one we can factor is this one. Everything else stays the same because they're not factorable. So in that yellow part that I highlighted, the method for factoring that one, the only thing that we can do is GCF, okay? And its GCF is 6 for the 6 and 18 pieces. And then the GCF is m squared for the m pieces, the m cubed and the m squared. So I'm going to take a second and rewrite this so that it is factored. So the m3 up top is the same. 6m squared on the bottom leaves me m plus 3. Now look at that first fraction. What is the same on top and bottom now that can be canceled? The m plus 3, right? And anytime you divide something by itself, what are you left with? You're not left with 0, you're left with a 1. And so now that we have taken care of that, we will multiply the 2 fractions. When you multiply fractions, you multiply across the top and across the bottom. So we have this 1 now times this m minus 8. Of course, multiplying by 1 doesn't change anything, so it's still m minus 8. And then on the bottom, we have 6m squared times 2m, which we can actually multiply that. It's 12m cubed, and then we have m minus 8 on top. No, I paused it. Now I'm recording, so thanks for one heads up that a common mistake that I don't want you to make is right here. A lot of times I'll have students try and cancel stuff here. They say, oh, look, there's an m on top and bottom, and they'll cancel it out. Or they'll say, oh, there's an 8 and a 2. That simplifies to 4. But here's why you can't do that. Because of this minus right here. The only time you cancel stuff is when it's factors. And factors are things that are being multiplied. That m and 8 are not being multiplied together. They're being subtracted. So they are not available for canceling out. You have to just leave it as a group, the m minus 8 together. So no factoring there. Okay. Number 4. Why is this not a keep, change, flip, or multiply by the reciprocal problem? Because it's not division, right? You're multiplying 2 fractions. You don't have to keep, change, flip anything. What we do need to do here is factor first before we can figure out what cancels. So look at all the numerators and denominators. Only one place needs to be factored. So find that place. It's this one, right? That is a trinomial. So we're not and it doesn't have any GCF, okay? So we don't have to, there's nothing in common that we can divide out. What we need to do is our cross method. So we ask ourselves what multiplies to AC. A is 1. So A times C is 2. What multiplies to 2 and adds to 3, because that's B, right? What multiplies to AC and adds to B. And that is 2 and 1. So I rewrite that middle term as 2m plus 1m. And then I have the first term m squared and the last term, and I do my grouping. The GCF here pulls out and leaves me m times m plus 2. There's the only thing in the second group that they have in common is just 1, so we pull the 1 out. And now they have m plus 2 in common times m plus 1. So I will rewrite that problem as this. And what cancels here? It kind of looks like nothing cancels, because if you're just looking at the second fraction, there's nothing on top and bottom that's the same. But since we're multiplying these two things, we can look at the top and bottom of the first fraction as well. And now when you're looking at both fractions at the same time, what do you see that's the same on the top and bottom? The m plus 1, right? So that can cancel out. And again, that leaves you a 1 up here. So then we multiply across the top, m plus 4, multiply across the bottom. You can leave your answer like this, or distribute on the bottom. Okay, you can get either one of these for an answer. It's okay. All right, so this is the, all right, so this problem right here is another keep, change, flip. Can you figure out why it's keep, change, flip? Because of this division right here. Okay, it's a division problem, and it's an ugly one. The first thing we want to do is rewrite this division, and this division problem is vertical, right? Top to bottom. We want to rewrite it horizontally, left to right. So here's the first step. Hold on one second. Actually, before we rewrite it horizontally, let's do this. We're going to just focus on this piece for a few minutes. 3 over x minus 2. Because if I were to do keep, change, flip, flip means you flip the thing that's on the bottom. But how do you flip 3 over x minus 2? It's two different things. It's two different terms. What we're going to do with that is make it into one fraction. Then we're going to start the keep, change, flip process. So don't think about the whole problem right now. Just think about that purple part that I circled, okay? And here's what we're going to do with that. We're going to get common denominator. We're going to rewrite it so they have the common denominators, kind of like we did at the beginning of the notes with numbers 1 and 2. We're going to find a common denominator. So the way it's written right here, it looks like 2 doesn't have a denominator, but we know that it's 1, okay? And it's real easy to get a common denominator here. It's just x times 1 is x, right? So the least common denominator is going to be x. And we don't have to multiply the first fraction by anything because it's already x. So technically just, multiply 1 times 1 and nothing really changes. The second fraction, though, needs to be multiplied by x on the top and bottom. So now this gives me 3 over x minus 2x over x. Denominator stays the same. You combine the numerators, and they have to stay the same because they're not like terms. So you just put them together, and you have 3 minus 2x over x. So here's what this means now for this problem. We have 4x minus 6 over 3 minus 2x over x. We did that so that when we go to keep, change, flip, we only have one fraction to flip now instead of these two separate things that didn't really make a lot of sense. We couldn't have just flipped it because they're not combined. Okay, so I'm erasing this work now so I can do the rest of the problem. All right, so like I said in the beginning, this is a keep, change, flip because we have a division bar right there. And we're going to start by rewriting this left to right instead of up and down. So I had 4x minus 6 divided by the new form of the denominator, which is a fraction. So keep, change, flip looks like this. Keep the first thing the same. I'm going to put a denominator there because I know I'm going to need it in a bit. Change the division to multiply and flip the second fraction. All right, so that's good. Just like in the last problem, we want to factor wherever we can. And the only place I see to factor is this numerator right here with a GCF. What's the GCF for those two terms? It's 2, right? Okay. So I've got 2 times 2x minus 3 over 1 times x over 3 minus 2x. All right, now look and find whatever you can cancel. That's the same on the top and bottom. Nothing, right? There's nothing that's exactly the same on any of the tops and bottoms. But if you look closely, there's two things that are almost the same. This looks like that. It's just the signs are opposite. Like if you rewrite 3 minus 2x, if you switch the order, it's negative 2x plus 3, which is kind of like the 2x minus 3 there, but the signs are different. So here's a, it's not really a trick, but it's just something to keep in mind. It'd be really great if this thing, the 2x was positive and the 3 was negative. If the signs were flipped. Well, how do we flip signs when we're like solving equations and we want to flip all the signs? We divide by -1, okay? That's what I'm going to do here. Think about it like this. Pull out a -1 as a GCF that they have in common. So if you did that, you'd have this. You'd say, okay, divide a -1 out of each of those things. And then what does -2x become? Positive 2x. And what does positive 3 become? -3. So let me rewrite this and show you what we have now. The first fraction is still the same. But now on the bottom of the second fraction, I have -1 times 2x minus 3. Now what do you see? That's exactly the same on the top and bottom. The 2x minus 3. And now we just multiply across the top. We have 2 left over here times that x. Multiply across the bottom, 1 times -1. And we can leave our answer like that or just like this, -2x. Okay. So that's a long problem. You have to take it in stages. The next problem, number 6, solving a rational equation. This is where we found a common denominator, and then remember we would draw the squiggly line to cancel out the denominators, and then we would drop them all off, and then just solve the numerators. Let's review that. So this is actually a pretty straightforward problem. The denominators are already all factored for you. What we need to do is rewrite them to all have the same denominators. The first denominator is x plus 2. The second one is x plus 2 times x minus 3. And the last one is x minus 3. We need them all to be the same. And so that means we need to multiply the denominators by something that makes match the rest of the denominators. And this is where we're going to start. This one. This one already has x plus 2 and x minus 3. What would this one need to be multiplied by to match that one? X minus 3, right? So we do that to the top and bottom. What does this one need to be multiplied by to match that one? X plus 2. And we have to do that to the top and bottom. So now that I have put those red fractions in there, x minus 3 on the left, and x plus 2 on the right, notice the denominators are now all the same. X plus 3 times x minus 3 times x plus 2, x minus 3 times x plus 2, x minus 3 times x plus 2. Now that they're all the same, and because this is an equation, just drop those off. And now just do math on the numerators. So once the denominators are gone, here's what I have left across the top. X minus 3 times 3 plus 1 equals 1 times x plus 2. And now we just solve. This is a regular equation. Distribute the 3. 3x minus 9 plus 1. Distributing the 1 doesn't really change anything over here. Combining these two numbers gives you 3x minus 8 equals x plus 2. Now we will get all the x's on one side and the constants on the other. So I will subtract x here, add 8 here, and that gives me 2x equals 10, and then divide by 2, and x equals 5. And then take a moment and pause your video and read that word problem on the bottom. All right, so Frank and Sarah have this rental property. It cost $324,000 to purchase. They are renting it for $3,000 a month. Okay, so this is asking us how many months is it going to take before they see a profit, right? Because they're using that $3,000 a month to pay off what they bought it for, right? They owe that. They're paying off a bill. They're paying off their mortgage. How long before they're making a profit? So this formula right here is setting that up for you. They're in debt this much. That's why there's a negative sign. But they're making $3,000 a month. So the 3,000 has a plus, and it's times M, because that's how many months we're looking for. How many months will it take before they're making more money than they spent? And then it's divided by that same number. Okay. So this CM right here represents their total profit. Well, it is showing the profit or loss. If you plugged in a value for M and your number was negative, that means you have a loss after that many months. If you plug in a number for M and the number is positive, that means now you're gaining profit each month. When that value equals 0, that is the break-even point. That means it took that many months just to pay off the $324,000. Anything after that is a profit, right? So what we just are going to do is plug in 0 for CFM to figure out how long it's going to take to just break even. So now we have this equation we can solve, and whenever there's something in the bottom, we can multiply both sides by that to get rid of the denominator. So on the right-hand side, those would cancel, and on the left-hand side, well, what is m times 0? It's just 0, right? Now we do what to both sides because we're trying to solve for m. We add, right, we add 324,000 on both sides. Now we divide by 3,000. So m equals 108. It's 108 months to break even, but that is not what the problem is asking us. It's saying how many months before they see a profit. So after charging rent on that property for 108 months, excuse me, they're finally broke even. They're no longer in debt. It's one more month after that that they start seeing a profit. So it will take 109 months for that to happen. All right. So now you're done with this video. Go try your practice problems. I'll make a video for that too in case you need to see that worked out. And then after that, you'll do your extra practice problems. Check yourself with the key and upload a pic of your work to Google Classroom.